Hi, my name is Ben Hutchinson, and I'm here to talk about evaluation gaps in machine learning practice. And this paper is really inspired by three very simple questions. Firstly, why evaluate machine learned models? Secondly, how in practice are machine learned models evaluated? And thirdly, ideally, how should machine learned models be evaluated? And we acknowledge that the practice may rarely, if ever, meet the ideals. We acknowledge that in practice, there may be simplifications and assumptions that need to be made. But we're concerned about the gaps that arise as a result. What are the gaps in our knowledge about the models that can result? And we argue that for this audience, these gaps are important because they can have moral consequences. So to get to the first question, why evaluate machine learned models? And really, the most important thing about this question is asking it, because it presupposes that there may be more than one reason to evaluate a model. What is it, though, that we mean by model evaluation? Well, we use the term very broadly in this paper. When evaluating a model, you might use some data to feed it through the model. You might perform some calculations of evaluation metrics, but we really don't want to preclude any broad form of evaluations, including qualitative studies and studies that produce something other than just metrics. The first class of evaluations we want to mention are those of learner-centric evaluations. And these are evaluations which aim to tell us something about the provenance of the model, maybe to learn something about the learner, its model architecture, maybe a new learning algorithm, maybe to learn about the effect of some hyperparameters or of some set of tuning data. However, another set of reasons for evaluating a model are to understand its appropriateness in an application within some ecosystem of model use. Is this model appropriate given it will be an application that will interact potentially both with people and with computer systems? The second question, how in practice are machine learned models evaluated? And to look at this question, we decided to look at 200 papers from major conferences in the fields of natural language processing and computer vision. And we coded these papers as to what types of metrics were reported, as to what types of test data was used in the evaluations, as well as other practices, such as did they report statistical significance or error bars and so on. And the main finding, and this may be the least surprising finding of this conference, is that the archetypal research evaluation reports model accuracy on test data, which has the same distribution as the training data. And we say this is not surprising because this is typically how machine learning practitioners are trained to evaluate models. We should mention that there's nothing about these fields that necessitates that a paper at these conferences has to contain an evaluation of a machine learned model. However, we found that in practice, almost every paper at this conference did contain at least one evaluation of a machine learned model. We also found that reporting of epistemic uncertainty was uncommon, such as reporting confidence intervals or error bars. Similarly, systematic analysis of the errors made by the model was rare, and sliced or disaggregated analyses were uncommon as well. To get to the third question, how should machine learned models be evaluated ideally? And here, all we want to say is that the how of a model evaluation should depend on the why. In other words, the why is prior to the how. We argue it's important to establish and document the why. So given that the practices may not always meet the ideals, we wanted to explore what are the types of assumptions that may be made in the process. And to do this, we asked the question, what are the gaps between the is and the ought? This slide has an image of an ivory tower. So to explore these assumptions, we asked the question, are the model evaluation practices used in the machine learning research communities, the practices we just reported on, are they appropriate for machine learning application developers? And the reason we think this is an interesting and important question are twofold. Firstly, because machine learning researchers are often lionized and highly valued, and their practices may be copied because of that. Secondly, it's quite common for practitioners to move from a research background into industry, into application development, and to bring their practices with them. So to represent, for the purpose of this, what the goals might be of an application developer, like very broadly, we say the goal of evaluating a model for an application is to understand the appropriateness of that model within an ecosystem. I mean, I asked, is there a set of assumptions that might be made or simplifications that would lead from this ultimate goal to actually, in practice, simply reporting accuracy on data with the same distribution as the training data? And if so, what are these assumptions? And if so, what are the knowledge gaps that result from that? In the paper, we talk about 6 different assumptions. And we don't claim to be the first to have identified any of these, but we think that by arranging them systematically in this way has a lot of value and use. The 6 assumptions we identify are firstly consequentialism, i.e. a focus on the first order impacts of the model. Secondly, abstractability from context assumption, that is ignoring system effects. Thirdly, what we call the input myopia assumption. This is the idea that in an evaluation, the most important thing is to compare the model predictions with the ground truth labels. And once you have the model predictions, the inputs to the model are really not important anymore. Fourthly, there's a range of quantitative modeling assumptions. Fifthly, it's common to assume that different failure cases of the model are equally important. And lastly, an assumption that the test data you're using has ecological validity for the ecosystem you care about. So in the paper, we show how these 6 assumptions taken together, they chain in sequence to lead from this ultimate goal of understanding a model, the appropriateness of a model for an ecosystem. They chain towards this simplification of reporting accuracy on test data from the same distribution as the training data. Firstly, the consequentialism assumption leads to the simplification that we only care about the utility of the model in the ecosystem. Secondly, the abstractability from context assumption says actually all we care about really is just the model inputs, the model outputs, and the ground truth labels. And that's all we need for the evaluation. Thirdly, the input myopia assumption says actually once we have the model predictions and we have the ground truth labels, we don't really need the model inputs anymore. Fourthly, there's a set of quantitative modeling assumptions which lead to utility being calculated as an average or an expectation of utility over individual data points. So here there's an assumption that that averaging is a meaningful thing to do. Fifthly, in classification tasks, this reduces to saying, well, actually, the likelihood of the model prediction being the same as the ground truth label is all that we care about. And lastly, assuming that the test data that we have represents the actual distributions in the ecosystem. So taken together, this all leads to a calculation of the likelihood of the model prediction being equal to the ground truth label calculated over the test data. In the paper, we talk about the different knowledge gaps that result, or the different things that are minimized by making these assumptions. For example, the consequentialism assumption leads to minimizing our obligations to people. For example, obligations towards people whose data we may be using. The abstractability from context assumption obviously minimizes system effects, but also can serve to bake in a single idea of ground truth and in the process minimize the importance of subjectivity. The input myopia assumption, by minimizing the input to the model, means we can't do things like disaggregated analyses or explore the input space for regions in which model performance may differ. Fourthly, the quantitative modeling assumption means we can't handle things that are not commensurable. The equivalent failures assumption ignores there may be disparate harms and benefits both of model failures, but also of model successes. And the test data validity assumption, obviously, a risk of data drift between the test data and the ecosystem. This slide has an image of a mind the gap sign. So in the paper, we argue that it's important to document the motivations for an evaluation. We argue that, of course, the practices may never meet the ideals. And so it's important to document what assumptions you're making when evaluating a model, and also whose subjective perspectives you're baking in to certain ideas such as ground truth. In making some assumptions, you'll be introducing certain knowledge gaps, and we advocate for exploring these gaps once you're aware of them. For example, if your evaluation is primarily quantitative, then even doing a small scale qualitative study may really help to shed additional light. And lastly, it goes without saying that for this audience, consider evaluating for bias, sensitivity, robustness, and safety. I want to finish by talking about an idea from Karen Spark-Jones. She was a true legend, doing decades of important work in information retrieval. She got a Lifetime Achievement Award by the Association of Computational Linguistics for her work in natural language processing. But she was underappreciated for most of her career. And she didn't become a full professor until the age of 64. And one of her proposals from 1995, almost 30 years ago, was for evaluation remits. An evaluation remit serves to establish and document the motivations for an evaluation, whose interests prompted the evaluation, what perspectives are adopted, who are the consumers of the results. Also, what are the goals? What is it that we want or need to discover? She argues that the evaluation remit is prior to the evaluation design. That is, the why is prior to the how. And I'll finish with a quote from John Tate about Karen Spark-Jones. A lot of the stuff she was working on seemed like mad nonsense, and now we take it for granted. Thank you.